Today we will be covering Lesson 3-3 on compound inequalities. Our lesson for today will be split into 5 separate sections. In the first section, we'll cover questions 1 and 2. 1 and 2. So let's go ahead. On the previous slide, you should have seen this paragraph that says, compound inequalities are two inequalities joined by the word and or by the word or. Inequalities joined by the word and are called conjunctions. Inequalities joined by the word or are called disjunctions. You can represent compound inequalities using words, symbols, or graphs. For instance, we're going to start with question number 1. Number 1 says, complete the table. The first 2 rows have been done for you. The first row says all numbers from 3 to 8 inclusive. Now, inclusive means including. Okay, so notice that they said some of their possible solutions were 3.5, 4, 4 1/3, 5, 6, 7.9, and 8. Now, if I wanted to write this inequality-wise, I would say all the numbers from 3 to 8, well, that's any number greater than or equal to 3. And it has to be smaller or less than or equal to 8. And when they graphed it, they had a closed circle at 3, a closed circle at 8, and all the numbers in between. Because it has to satisfy both being bigger than 3 and smaller than 8 at the same time. Let's take a look at the second line that's already been done for us. All numbers less than 5 or greater than 10. So they said, well, -2 is less than 5. 0 is less than 5. 3 is less than 5. 4 is less than 5. 4.8 is less than 5. Then it also has to include numbers that are bigger than 10. So 10 and 3/4 greater than 10. 11 greater than 10. So they wrote this as 2 separate inequalities, and the first one said x is less than 5, or, because we've used this word right here, x is greater than 10. So they have an open circle at 5 pointing to the left and an open circle at 10 pointing to the right. Let's take a look at line 3. All numbers that are greater than -1 and less than or equal to 4. So notice we got this word and here in the middle. Okay, so I want numbers that are bigger than -1 and also are less than or equal to 4. So some possible solutions. Well, I can't include -1 because -1 is not greater than -1. But I could include -0.5. Other numbers that can be included are 0. We could go with 2, because that's bigger than -1, but it's also less than or equal to 4. Let's see. We can do 3. I could do 3 and 2/3. I could even do 4 because it says or equal to. So I can equal to it as well. Okay. So whenever I write this, the first thing I'm going to do is put all numbers greater than -1. So x greater than -1. And then I'm going to write that word in the middle, and x is less than or equal to 4. So when we go to do our number line here, I'm going to plot some important numbers. We got 0. We'll go 1, 2, 3, 4 to the right-hand side, right? And then I'll go -1, -2, -3 to the left-hand side. Now, because of the way that I'm doing it, I wouldn't be able to get like a dark mark here. So I'm actually going to draw mine above the line itself. The first thing I've got is x is greater than -1. So all the numbers greater than -1, but not including 1, would be an open circle, and it would be pointing to the right. Okay? And I want x is less than or equal to 4. So we're going to have a closed circle at 4, and it's going to be pointing to all the numbers that are to the left-hand side. Okay. Now, because we're talking about the word and, I want where the two graphs overlap one another, where they're the same. So I would have an open circle at -1, a closed circle at 4, and everything in between. So just the sections that kind of overlap is what goes on my final picture here. Okay, let's take a look at row 4. All numbers less than or equal to 3 or greater than 6. So numbers that are less than or equal to 3. Okay, so I could be including numbers like 3, obviously, right? And again, I want numbers that are less than or equal to. So I could also include numbers like 2. I could do 0. We've got -1. I could even do -2 4/5. Okay. All those numbers are less than or equal to 3, right? And it says I also can include numbers that are greater than 6. So some numbers that are greater than 6 would be things like 7, 9, 20, and the list could go on and on, right? So how would I write these in an equality form? Well, let's start with the first one. Less than or equal to 3. So x less than or equal to 3. Notice this keyword in the middle, or. Numbers greater than 6. So I would write x greater than 6. So I got some key numbers I need to put on here. We're going to have 3, got to go 4, 5, 6, we'll go 7 and 8. Here I'm going to do 2, 1, and 0. Okay. Now, because it uses the word or, it can be either this or that, right? So I can have numbers smaller than or equal to 3. So close circle at 3, pointing to the left. Open circle at 6, pointing to the right. Now, notice there's no overlap here, but that doesn't matter because we're using the word or. So when we finalize our graph here, we're going to have closed circle at 3, pointing left. Darken up my line here. And open circle at 6, pointing to the right. Okay. Let's take a look at question number 2 now. It says, use the graphic organizer to compare and contrast the graphs for the conjunctions or disjunctions. Now remember, conjunctions use the word and. So these are my and ones, and disjunctions are my ors. Okay. So let's take a look here. Similarities. Well, they both show a range of numbers. And it says we're comparing the graphs, okay? So both graphs show a range of numbers. Okay? Let's talk about the differences. When you use the word and, what did we notice about our graphs? Well, we use the word and here and the word and here. So I notice here I have one official line segment. Same thing with here. So when using the word and, the graphs have one line segment. Between two numbers. And the ones with or have two rays going in opposite directions, as seen here in line 2 and line 4. We have rays, but they're going away from one another, not coming towards each other. Okay? On to your debriefing question.